Hello students, welcome to another session, or we can say part 2 of Thermochemistry lecture. I hope all of you have revised part 1 of Thermochemistry, and the points which we have covered in part 1 of the lecture was about the thermochemical equation, heat of reaction, and the factors which affect the heat of reaction. So that was all in the lecture 1. Today we have come to part 2 of the series, in which we are going to discuss about Hess law of constant heat summation and different types of heat of reaction. So without wasting any time, let's dive into the topic. Let's unlock the mystery behind the chemistry of thermochemistry. So as I said, we are going to start with Hess law of constant heat summation. We are going to start with Hess law. Now, let's take a simple example, and with the help of that example, we'll try to understand that what is Hess law. We are taking a simple example, and with the help of that, we'll try to find out the Hess law. Now, let's say I have to go from Hyderabad to Delhi. Now, I can choose multiple paths by which I can go from Hyderabad to Delhi. One possible path is I'll go from Hyderabad to Mumbai and then Mumbai to Delhi. Another path will be Hyderabad to Visakhapatnam and then from Visakhapatnam to Delhi. Or I can directly go from Hyderabad to Delhi. So there are multiple paths by which we can go from Hyderabad to Delhi. But whatever path we select, our displacement in all the three cases, that will remain same. Whether we go via Mumbai or we go via Visakhapatnam or we directly go to Delhi, the displacement will always be same. And such a function which is not depending on the path, that is known as a state function. So same is the case with enthalpy or internal energy. Enthalpy or internal energy is also independent of the path which is followed. Means it will only depend, or we can say the change in enthalpy or change in internal energy will only depend on the initial state and the final state. It does not matter by which path we are changing our state. So let's take a simple example. For example, let's say we are having carbon solid. Now this carbon solid has to be converted to CO2 gas. Carbon solid has to be converted to CO2 gas. So let's say one path is from carbon solid, let's say we are forming carbon monoxide by treating it with half moles of O2, and then from carbon monoxide we are converting it to carbon dioxide by again reacting with it with half mole of O2. And another way to convert carbon solid to carbon dioxide is by direct addition of 1 mole of O2. So these are two paths by which carbon solid can be converted to carbon dioxide. Now let us say in the first path, delta H1 is the change in enthalpy when carbon is converted to carbon monoxide, and delta H2 is the change in enthalpy when carbon monoxide is converted to carbon dioxide. So over here, for conversion of carbon solid to carbon dioxide, total change in enthalpy will be equal to delta H1 plus delta H2. Now, when carbon solid is converted to carbon dioxide via the second path, means by addition of 1 mole of O2, let us say change in enthalpy is delta H3. So for down path, delta H is coming out to be delta H3. Now, as we know that enthalpy is a state function, it means whether we go by above path or we go by bottom path, top path or bottom path, in both the cases, the change in enthalpy will be same. So I can write using these two that delta H1 plus delta H2, which is change in enthalpy of first path, will be equal to our delta H3, will be equal to our delta H3. Now, let me write all the three equations again. Let me write all the three equations again. So equation was first carbon solid plus half O2 gas is giving us carbon monoxide gas. For this reaction, change in enthalpy is delta H1. Then carbon monoxide gas plus half of O2 gas is giving us carbon dioxide gas. So for this path, change in enthalpy is delta H2. And third reaction is carbon solid plus O2 gas is giving us CO2 gas. And for this, change in enthalpy is delta H3. Now, if we name the reaction as this as reaction 1, this as reaction 2, this as reaction 3, then we will notice that reaction 1 plus reaction 2 is giving us reaction 3. If you notice it carefully, you'll find that if I add reaction 1 and reaction 2, what it will give? It will give us reaction 3. Carbon monoxide will be cancelled out and we'll get the third reaction when we have added 1 and 2. And we have also seen that delta H1 plus delta H2 is equal to delta H3. So from these two, what we can conclude? We can conclude one point that whatever operation, whatever mathematical operation we are doing on the chemical reaction, same mathematical operation can be performed on the value of delta H of the reaction, or same mathematical operation can be done for the delta U of the reaction. And this law is our Hess law of constant heat summation. This law is known as constant heat of summation. So this only will be used while doing problems based on thermochemistry. So I hope all of you have understood this. Let's take one example, then it will be more clear to all of you. So example is A plus 2B is giving us C, and C plus D is giving us E plus B. C plus D is giving us E plus B. Let's say for first reaction, delta H is equal to plus 10 kilojoule per mole. And for second reaction, delta H is minus 15 kilojoule per mole. So question is, find the delta H for the given reaction. Find the delta H for the given reaction. Given reaction is A plus B plus D giving us C. A plus B plus D is giving us C. So how can we solve this problem? So let's see. We can write this equation as 1. We can write this equation as 2. And we can write this equation as 3. Now if you do 1 plus 2. If you do 1 plus 2, so we'll get A plus 2B plus C plus D. This is what we have on the reactant side. Will give us C plus E plus B. This is what we have on the product side. Now cancel the common terms. So this C and this C is cancelled out. This B and this B is cancelled out. So we will be left with A plus B plus D is giving us E. Right? And this is what? This is our third equation. So I can write 1 plus 2 is equal to 3. And if I'm obtaining third equation by adding first and second, then delta H of the third reaction can be obtained by adding delta H of first and second reaction. So I can write delta H of third reaction will be equal to delta H of first, which is plus 10, plus delta H of second, which is minus 15. So this will be equal to minus 5 kilojoule per. So like this, they will frame question in the examination, in which they will give the reactions and they will ask you to find the delta H of one of the reaction, which will be obtained either by adding the two reactions, subtracting the two reaction, by multiplying by any coefficients. Let's take one more example. Let's take it is given that A plus B is giving us C plus D. Delta H for this reaction is plus 10 kilojoule per mole. They are asking find delta H of the given reaction. Find delta H of the given reaction. Given reaction is 2A plus 2B giving us 2C plus 2D. So what we can see that given reaction can be obtained by multiplying the first reaction. Let's say this is reaction 1. So and this is reaction 2. So what I can notice is reaction 2 is equal to 2 times reaction 1. Reaction 2 is 2 times reaction 1. So same mathematical operation we can apply to the value of delta H of the reactions. So I can write delta H of second reaction will be equal to 2 times delta H of first, which is plus 10 kilojoule per mole. So this will be how much? Plus of 20 kilojoule per mole. So I hope you are liking the video. If you are liking it really, then please like the video. And if you have not subscribed the channel, do subscribe it now. And if you have any doubt, do make a comment. If you are liking the video, then also please make a comment. Okay, fine. So I hope you are clear with this problem. Let's move to another concept, that is different types of heat of reaction. So we'll start with types of heat of reaction. So we have discussed before that heat of reaction is the energy which is exchanged. Energy which is exchanged when a reaction is taking place. It is the energy exchanged during a particular reaction. Now, the name of that heat depends on the name of the reaction. For example, if we are having a neutralization reaction, then that heat is known as heat of neutralization. Let's say we are having a combustion reaction, then that heat will be known as heat of combustion. Same way, let's say we are having sublimation reaction, then that heat will be known as heat of sublimation. Let's say we have a formation reaction, then that heat will be known as heat of formation. Which means the name of heat of reaction depends on what? It depends on the name of the reaction. Is it clear? It should be very clear, because all the heat we have to define now, and it will be based on what? It will be based on the name of those reactions. So let's start our discussion with the first type, which is heat of formation. First one is heat of formation. So heat of formation represented by delta F and H. F stands for formation. So how do we define heat of formation? So it is defined as the amount of energy. It is defined as the amount of energy exchanged. Amount of energy exchanged during the formation of 1 mole of a compound, during the formation of 1 mole of a compound from its constituent elements, present in their in their standard state. Present in their standard state. So let me tell you again, it is defined as the amount of heat or amount of energy exchanged during the formation of 1 mole of a compound from its constituent elements present in their standard state. Now, if you can notice, I have marked few points or I have underlined few words. First one is energy exchanged. When I'm saying exchanged, it means two things. What does it mean? First, that delta H for this reaction can be either positive or delta H of this reaction can be negative. It means energy can be required for the formation or energy can be released during the formation of substance. That is one point. So we cannot tell that it is always exothermic or it is always endothermic. It can be both. It can be exothermic in some cases, endothermic in some cases. Next, it should be formed. It should be the formation of that particular compound. How much compound should be formed? That also is important. That 1 mole of compound should be formed. If 2 mole is formed, if 2 mole is forming, then that is not defined as heat of formation. For heat of formation, it should always be 1 mole. Next, it should be formed from its constituent elements. Like if I'm having ammonia, then ammonia should be formed from nitrogen and hydrogen. If I'm having water, then water should be formed from hydrogen and oxygen. If I'm having carbon dioxide, then it should be formed from carbon and oxygen. And those constituent elements, next and very important, is that it should be present in their standard state. Now, what is the standard state? Let's say if I'm talking about carbon dioxide. So, carbon can exist in multiple forms, like carbon can exist as graphite, carbon can exist as diamond, carbon can exist as Buckminster fullerene, coal tar. There are multiple forms of carbon. So, which one is taken as a standard? So, carbon graphite is taken as a standard. So, CO2 should be formed from carbon graphite. Then only it will be termed as heat of formation. Same way, if you see oxygen, oxygen can exist as O2 molecule or it can exist as O3 molecule. It can be O2 or it can be O3. So, standard is O2 molecule. So, if whenever oxygen is present, it should be O2 gas. Whenever carbon is present, it should be carbon graphite. So, let's see some standard states. Standard state of some elements. Standard state of some elements. Carbon is carbon graphite. Next, oxygen is O2 gas. Nitrogen is N2 gas. Hydrogen is H2 gas. Sulfur is S8 rhombic sulfur. S8 rhombic sulfur can have rhombic form, monoclinic form. There are multiple allotropes of sulfur. So, rhombic form is standard. Fluorine is F2 gas. Chlorine Cl2 gas. Bromine is Br2 liquid. Iodine is I2 solid. Mercury is Hg liquid. Sodium is sodium solid. For metal, it is metal in their solid state most of the cases. So, these are some standard state of some elements which are important and which will be used in the questions. Now, let's take some examples. Let's say if I'm having a reaction N2 gas plus 3H2 gas is giving us 2NH3 gas. Delta H of this reaction, let's say, is X. Now, question is this X our heat of formation? So, we can see that NH3 is getting formed from its constituent elements present in their standard state. But the problem is that per mole of the reaction, we have 2 moles of NH3 getting formed. And because it is 2 moles of NH3, that is why this is not the heat of formation. It is not the heat of formation. Now, if I want the heat of formation of NH3, what we have to do? So to find heat of formation, there should be formation of 1 mole of NH3. And to make it 1, to make the coefficient of NH3 1, we have to divide this reaction by 2. So if I divide this reaction by 2, this will become half of N2 gas plus 3 by 2 of H2 gas will give us NH3 gas. Now, for this reaction, what will be delta H? So, as we have divided the above reaction by 2, that is why delta H of this reaction should also be equal to delta H of above reaction divided by 2. Now, this X by 2 will be what? This is our heat of formation of ammonia. Why we are saying it as heat of formation? Because you can see 1 mole of ammonia is getting formed from its constituent elements which are present in their standard state. Let's take one more example. Calcium carbonate solid on heating gives us calcium oxide solid plus CO2 gas. Let's say delta H of this reaction is Y kilojoule per mole. Y kilojoule per mole. Now question is this Y the heat of formation of CO2? So answer will be no. This is not the heat of formation of CO2. The question is why? Why this heat is not the heat of formation? So answer is that in this reaction CO2 is not getting formed from its constituent elements. Rather, it is obtained as a product of decomposition of calcium carbonate. So if you want the heat of formation of CO2, what reaction we should write? So it should be carbon plus oxygen giving us CO2. Now carbon in which form? So carbon in its standard state. So it will be carbon graphite plus oxygen in which form? O2 gas will give us CO2 gas. Delta H of this reaction will be equal to what? It will be heat of formation of which compound? Heat of formation of CO2. Am I clear with this? Let's take one more example. If I write C diamond plus O2 gas giving us CO2 gas. Now, is this heat of reaction our heat of formation of CO2? So, answer is no. This is not equal to heat of formation of CO2. Now, again, same question. Why it is not heat of formation? Because carbon is not present in its standard state. For heat of formation, the element should be present in the standard state. So, I hope all of you are becoming clear with this. Let's see a few more points. Heat of formation of elements in their standard state is taken as 0. Heat of formation of elements in their standard state, like whatever we have seen, O2 gas, N2 gas, H2 gas, Hg liquid, I2 solid, Br2 liquid, whatever elements we have seen, for them heat of formation is taken as 0 in their standard state. Now let's see a statement. Statement is heat of formation of H2O is equal to 0. H2O liquid. Heat of formation of H2O liquid is equal to 0 because H2O is present in its standard state. H2 is present in its standard state. Now tell me, this statement is true or false? Heat of formation of H2O liquid is equal to 0 because it is present in its standard state. This statement is true or false? So answer is false. Why it is false? Because heat of formation of element in their standard state is 0. H2O is not an element. H2O is a compound. That is why its heat of formation will not be equal to 0. Now, how will we define heat of formation of H2O liquid? So, it will be H2 gas plus half of O2 gas will give us H2O liquid. Delta H of this reaction will be equal to heat of formation of H2O. Okay, one more example we forgot to write in this. For phosphorus, it is P4 white. White phosphorus is the standard state. White phosphorus is the standard state of phosphorus. Fine. So, this point you have understood. One more point. Heat of formation of H plus ion is taken as 0. This is again an important point which is used in the questions. Heat of formation of H plus ion is taken as 0. Heat of formation of H plus ion is taken as 0. Fine. So this also I have understood. Now let's take one question. Question is, find the heat of reaction. Let me write like this. Find the heat of reaction for the following reaction. For the following reaction. Reaction given is CaCO3 solid giving us CaO solid plus CO2 gas. Given heat of formation of calcium carbonate is equal to X. Heat of formation of calcium oxide is equal to Y. And heat of formation of carbon dioxide is equal to Z. Now, how can we solve this question? So, there are two methods to solve this. First method is using using Hess Law, and second method is using the formula. Formula I'll tell you later. First, we'll understand how to solve using Hess Law. So, what we have to do in this for solving this question, we will write the heat of formation reaction for all the species which they have provided. So they have provided heat of formation of calcium carbonate, calcium oxide and carbon dioxide. So let's write the reaction. Now for formation of calcium carbonate solid, heat of formation definition says that it should be formed from its constituent elements present in their standard state. Now, calcium carbonate, constituent elements are calcium, carbon and oxygen. So, let's write the reaction. Calcium is metal, so calcium solid, plus carbon is carbon, graphite, plus oxygen is O2 gas. Now, in the product, we can see 3 oxygen atoms are there. So, what we have to do? We have to multiply this by 3 by 2. So, 3 by 2 into 2 of oxygen O2, it will become 3. So this value they have given that delta H is equal to X. Same for calcium oxide, we can write calcium oxide solid. It is made up of calcium and oxygen. So we'll write the reaction calcium solid plus half of O2 gas is giving us calcium oxide solid, and delta H for this is Y. And the third reaction is carbon graphite plus O2 gas is giving us CO2 gas, and delta H for this is Z. This is equation 1, this is equation 2, this is equation 3. Now if you see, the target equation or the given equation was calcium carbonate solid is giving us calcium oxide solid plus CO2 gas. Now, in the final equation, we can see that calcium carbonate is present on the reactant side. So what we have to do? We have to reverse the first reaction or flip the first reaction. So if I reverse this, we'll get, let me write over here, CaCO3 solid is giving us calcium solid plus carbon graphite plus 3 by 2 O2 gas, and delta H for this reaction will be minus of X. Let's take this equation as 4. So we'll take 4 plus. We want calcium oxide on the product side, and in this case calcium oxide is on the product side, so we'll add reaction 2 to this. And then we want CO2 on the product side, and in the third reaction we can see CO2 is on the product side, so we'll also add third reaction. Now let's see what is happening. If I add 4 plus 2 plus 3, we'll get CaCO3 solid plus from second reaction we'll get calcium solid plus half of O2 gas. From third reaction we'll get C graphite plus O2 gas will give us, from the first reaction we are getting calcium solid plus carbon graphite plus 3 by 2 O2 plus CaO solid plus CO2 gas. Now see, calcium solid cancelled out. O2 plus 1 by O2 will become 3 by O2. This is also cancelled out. Carbon graphite cancelled out. So ultimately it has become CaCO3 solid is giving us calcium oxide solid plus CO2 gas. Now this only was our desired equation. So we are getting the desired equation by adding 4 plus 2 plus 3. That is why delta H of this reaction can also be obtained by adding the delta H of reaction 4, reaction 2 and reaction 3. So if I add, it will become Y plus Z minus X. So this is the delta H of our final reaction. This is the delta H of our final reaction. Now using this we can write one formula also, that heat of reaction. We can write a general formula that heat of any reaction. In terms of heat of formation, I can write heat of formation of products, or summation of heat of formation of products minus summation of heat of formation of reactants. Summation of heat of formation of reactants. Now, this is the formula which we can also use to solve the questions if heat of formation is given in the question. Now, let me give a general expression. Let's say we are having a reaction AA gas plus B times B gas, giving us C times C gas plus D times capital D gas. Let's say X1, X2, X3 and X4. These all are values of heat of formation of these species. So if I want to find heat of this reaction, then we will write it as C times heat of formation of C plus D times heat of formation of D. This is summation of heat of formation of product minus summation of heat of formation of reactant. When I am writing, it will become A times X1 plus B times X2. So my point is, when I am writing summation of heat of formation of reactant or summation of heat of formation of product, we have to multiply by the stoichiometric coefficient, and that will give us the method 2 to solve this reaction. So I will suggest always go for method 1 rather than method 2, because method 2 is only specific for heat of formation. But if you are using method 1, you will be able to solve all the questions of thermochemistry. If you are clear with method 1, you don't have to remember any other formula also. So this much was in heat of formation. I hope you have understood the basics of heat of formation which will be used in solving the problems. If you have any doubt, make a comment. If you are liking the video, if the quality of video is good, then also make a comment. That will motivate me to make all such beautiful and interesting and conceptual videos. If you want any other topic, then I will be more than happy to make a video on those topic also. So this was all about part 2 of thermochemistry. Next, in the coming next part, we'll be discussing more about different types of heat of reaction. So keep practicing, keep studying. All the best.